Hello and welcome. In this lecture, we're going to be understanding the main steps involved in compiling C++ files in Unreal. Let's dive in and see how they work. So it's soon going to be time for us to start using code from the outside, from other files, and we need to learn how this works in C++. To do that, we need to take a little bit of a detour and understand in more detail what's going on when we compile our C++ code into binary. So here are the compilation steps that are used. We start off with your code, your C++ files, your header files, all in various text files. These get fed into a tool called the Unreal Header tool. Now, this tool is responsible for taking all the Unreal specific pieces of syntax and using them to generate more C++ code. So let's have a look at some examples of where we've got this Unreal specific syntax. This U class in capital letters, that is Unreal specific syntax, and so is the CryptRaider API thing here and the generated body there. And basically what's going on here is the Unreal Header tool will see these different pieces of syntax in your code and go, okay, I need to do my job. I need to go in there and need to add a bunch of stuff. It's going to replace your generated body with a bunch of code that makes our lives easier when using Unreal. It also does things like the U properties and U functions. It adds all the stuff that it needs so that it can communicate with the blueprint world. So that is the first step. It converts all of its Unreal specific stuff into actual C++. Once we've got the actual C++, we can then feed it into a standard C++ compilation process, which takes 3 steps. The first is to deal with the pre-processing step. So this doesn't actually touch any of the C++ syntax and actually only deals with lines that start with a hash. So we've got a few of these pre-processing directives. These are dealt with by the preprocessor. The next step is what we actually call the compiler. It takes our code and it converts it into executable binary, but it doesn't quite complete the step because it only does it on individual C++, what are known as translation units, basically C++ files. So it takes a C++ file and it translates that into binary individually, each individual C++ file. And then the third step is the linker, which brings all of that together and outputs an executable that we can actually run, a single executable. So let's have a look at these standard compilation steps in a little bit more detail with an example file. So imagine that we had a game.cpp, and it's a very, very simple game because all it does is add 1 and 1 together. But to add 1 and 1 together, it is having to use a function that's declared in a different file, in the math.h. So the math.h declares add, but it doesn't actually define what it does. So that is done over in the math.cpp, and you can see it's a very simple implementation indeed. Now, what happens at the preprocessor step? Well, like I said, it deals with any preprocessor directives, which are things that begin with a hash. So the hash include math.h basically means just copy everything in math.h into here. So what it does is it takes these 2 files and it combines them together to create a new output file called game.i, basically game.include. And you can see that it has included the definition from math.h and it's replaced the hash preprocessor directive. So now game.i has got a definition for the add operation. And then we run the preprocessor on math.cpp, but because it doesn't have any preprocessor directives, basically nothing is changed there. The next step is the compilation. This is probably the most important and complicated step because what it does is it takes that C++ in each individual .i file and converts it into binary. But it's not complete binary because, for example, my game doesn't actually know how to implement add. It just knows the shape of that add function. So that needs to be filled in later, and that's filled in by the linker. So the linker is going to take the binary created for the game.obj file and the binary created for the math.obj file and bring them together to make a game.exe, which combines the binary for both, and finally is a complete executable that we can actually run because it's got the definition for everything it needs. Now, why do we have such a complicated process? The idea here is that it speeds up our compilation time, because if I only made a change to game.cpp, I don't actually need to run the entire compilation process. All I have to do is run the bits involving game.cpp. So I'd run the preprocessor only on the CPP, then I'd run the compiler only on the game.i, and then I can reuse the math.obj file from before. I don't need to recompile it because nothing has changed in that. Similarly, if I only changed math.cpp, I wouldn't have to recompile the game.obj file, which is why this is a more efficient process and why we're doing it in the first place. So I'd like us to do a little experiment and try and figure out, why do we include mover.h in our mover.cpp file? What's the reason for it? Why can't we just compile the C++ file without including mover.h? So the experiment we're going to do is we're going to comment out the hash include line. So using a double / to make a comment in front of that line, which will basically make it get stripped out by the preprocessor instead of the preprocessor replacing it with the contents of the file. We're then going to recompile, and I'd like you to have a look at the error messages that come out and see what it says, to see if you can try and understand what it is that we're including this mover.h for. Pause the video and have a go. Okay, welcome back. So let's put a double / at the beginning of this line, which basically makes it null and void. And then we're going to do a Control-Alt F11, and we're going to have a look at the output of live coding. So look, we've got some errors straight away, very, very early on. And what it's saying is that uMover is not a class or namespace. And there's some other stuff down here. It's saying that primary tick component hasn't been declared, that super isn't a class or namespace, getOwner is an unknown identifier. And basically what this is saying is, you've talked about uMover here, but you've not defined it anywhere. You've not declared it anywhere. So I don't know, the C++ compiler says, I don't know what this is. So that's why we are hash including the mover.h, because mover.h declares the class. It says a uMover is a class and it derives from uActor component and it's got these methods, etc. It's declaring what it means to be that class. So without that declaration, the C++ compiler can't continue. And that's why we need to include that header file. Great stuff. So hopefully you now understand a little bit better the process involved in compilation of C++, and particularly compilation of C++ in Unreal. I will see you in the next lecture.